Hello, I've been playing around with an OpenMV camera this week and experimenting with it for possible use as a flyby camera for a pick-and-place system. I'm not really sure if I'm going to build a pick-and-place, but the more experiments I do like this, I guess the more likely it's becoming. But anyway, that's the OpenMV camera down there. You can't really see it too well there, but I'll put a little picture of it here on the screen for you. And what it is a very capable STM32 chip. So that's an STM32 H743VI, and I think it has 2 megabytes of flash memory and 1 megabyte of RAM, which is quite a lot, and it has 480 megahertz processing, CPU clock. So it's quite fast, and it is on this little board there. There's not a whole lot else on the board, some LEDs and stuff. But there is obviously a camera, sensor, and a lens unit. That's not actually the sensor that came with it when I bought it. The one that came with it when I bought it is this one here. That is a color sensor. But I've replaced that with another one that you can get, which is a global shutter sensor. And I'm using the same lens unit there, just to screw that on top and adjust it to get the focus that you want. And all this other stuff here, let's have a look at this as well. So I have my Weenie PRU for Linux CNC, and that's connected to a Raspberry Pi 3. And I made this board here, designed that and ordered from JLC PCB, and it just lets you tip, or it lets you place the Pi flat on the same level as the PRU was. So previously the way I had this was the Raspberry Pi was flipped upside down and plugged into the header there, but it's a little bit inconvenient because these USB plugs here are actually taller, and it was just sort of crooked, and also didn't like that much of a mass of Raspberry Pi hanging off the side either. But this is quite nice because it would let me, if I wanted to, screw these down to this board all in the same plane. And so that's working alright. And connected to the PRU we have this is just a 5-volt power supply for the PRU. We have a stepper motor driver there that's running off this 36-volt hoverboard pack. This is a 3S battery, about 11.1 volts or so roughly, and that's powering what is it powering? Oh, it's powering this light ring, and it's also going into the BEC for the PRU as well. And this is up and running. Linux CNC is ready to go. I've got my LEDs showing me what's going on there, and when I push this button here, it will run the program. So there's a stepper motor under there, and it goes like that. And so this is a NEMA 23 stepper motor, and I have this piece of aluminium that I cut on my CNC machine, and it has some holes here equally spaced around the radius of this circular piece, and you can see that they're going to be swinging over the camera like that, like this, at about that speed. So it just goes over and back. This little power transistor here is so that the OpenMV can turn the lights off and on. So the OpenMV only has 3.38 volt outputs, of course, but this just lets that 3.3 volt output control the approximately 12 volts or so for the lights. And the OpenMV is not on at the moment, that's why we didn't see the lights turning on. But what's going to happen is one of these wires in this little rat's nest of wires here is going to output a signal. It's just going to make a digital pin go high at the exact moment that this first hole in the aluminium comes, maybe not exactly over the top of the camera, but pretty close to exactly, pretty close to over the top of the camera. And that lets the OpenMV unit know that it's time to start shooting, taking photos. So what it's going to do is it's going to take a photo at that moment, and then it's going to wait. It actually has to go to sleep for a whopping 24 milliseconds. It's doing nothing, and then it takes another photo when this hole is over the top, and this one and this one. So the whole process takes about 100 milliseconds in total, but roughly 70-ish or 72 milliseconds is actually just sleeping. And then while it's doing that, or after it's taken those photos, then it's going to look for some blobs in the photos. And then it's going to show us on this LCD screen each photo as it saw them. And then it's going to transmit over this UART connection here. So this is going into a little laptop over there. And on the other side of this, we just have it plugged into the UART pins on the OpenMV there. And on my laptop, I'm running the Arduino serial monitor. So there's nothing there yet. If I run the program, nothing happens, right? But if we turn the OpenMV on and just give it a moment to start up, okay, the screen's ready there. Now when I run this, we'll see that light flash, and for some reason the first time you do this, the timing is off, so just ignore that one. Every time from now on should be correct though. So if I run this there, you'll see so it takes the photos all at once and then it does the processing afterwards. That's why it's a little bit slower to show us that, but I'll press it again. Yeah, so we're seeing each of the 4 photos as it flew over the top. And they're not perfectly in focus, but they're pretty good. I think with a little bit stronger lighting, I could reduce the exposure time even more. I think it's 500 microseconds or something at the moment, so it's already pretty short, but and we're hoping to see these holes all in the same place, right? And you can even see that it's trying to find a black blob of a certain size, not too big. Most of these holes are a little bit too big, that's why it's not showing for all of them, but oh, it seems to be showing where there's a brighter ring around the outside, I think. And the numbers in the top left, for the first 2 frames, it's showing you about 100 milliseconds, or that's the number of microseconds, 105,000 microseconds. And that's the time that it takes between the first photo here and finishing the last photo there. So, like I said, there's about 72 milliseconds of that is just sleeping, doing nothing. And then the other 30 milliseconds is the actual work that it's doing, which is to copy the frame buffer into memory at each of these positions there. So that's the 100 and something 5, what was it? 105,000 or so, there we go. And then the 29,000, that is the number of microseconds that it takes to find the blobs and then send the result over the UART connection. Oh, so we've got something coming up on our UART now. So I set this to do a pretty simple output. For each of the photos, it just does that opening bracket. And remember the first time it didn't find anything because it wasn't like timed properly, but every time thereafter you can see that we have an opening bracket. So each opening bracket is for each one of the photos, and then you can see there's a comma separated pair of XY positions showing the locations of the blobs that it found in the photos. So unfortunately it's finding some that are not what we wanted to look at. Sometimes it's finding the large blob there, but not much. Anyway, I'm not worried about it not finding those blobs. Mainly at this point, those holes are just there to let me see that the timing is all set up correctly. And what I'm actually interested in seeing whether it can find is this kind of thing here for like smaller blobs that mimic something that's more like the size of an actual SMD component. So these are just pieces of paper that I've drawn little marks on to approximately simulate some kind of a SMD component. In reality, it would be the other way around. You'd be looking for a white blob on a black background, and you'd also need to do a little bit of pre-processing to get it to where you just only have 2 colors like this. So it would take a little bit longer than what we're doing here. It's quite impressive though that it can find these blobs in 25, so it's 25 milliseconds to do 4 of them. So that's approximately 8 milliseconds to do blob finding in one frame. But yeah, so what I'm going to do now is take these off. They're just stuck on here with a little bit of sticky tape, and I'm just going to stick them under there like that, and well, we'll just do that one and we'll see what we get with that. So you can see it's kind of, you can see just in that first frame it's found all of those 12 blobs that were there. Okay, I have those have all those pieces of paper stuck on there now, and you can see I did a little test there, and that seems to be working just nicely. We have a whole bunch of blobs found now. Look at them all. Quite a few. So let's just let's run this again, and I'll show you all of them as it goes through. So it's just drawing a green rectangle and a red cross for the center point of them. And just to remind you, the only reason we're seeing it so slowly here is because I'm making this LCD pause for 1 second so that we can actually look at them, right? But if I didn't do that, basically almost as soon as this piece is swung across, it's already finished, and the results are over here. So let's see, if I push the button now, it's basically as soon as I've lifted my finger off the button, they're already done. So go like that. It's really fast. So I'm thinking this would be fast enough that if your pick and place machine was carrying some components across, by the time it's moved away from the camera and gone to where it needs to put them down, the machine should have this information transferred, you know, to know what to do with them for the rotation and slight offset corrections perhaps. But you might be wondering, how does the OpenMV portion of this know what it's looking for? Because we've got all these different kinds of layouts of components, right? Oh, whoops, wrong button. So we've got one of those, and we've got one of those, and they're all a little bit different. But what you can do is you can also send information through this UART. So I'm going to do that now, and we do that by, well, I've just set up a very crude system, so I can put a 1 in here, and then just hit enter, I think. Now it doesn't do anything immediately because it's in a very, very, very tight loop at the moment, and it's just waiting for that, waiting for that input trigger. So while it's in that tight loop, I don't want it to be listening for any UART transmissions because that might slow it down. We need that trigger to be at the perfect time. So what I made it do is that after it's done a trigger, so I'll push the button to trigger it, and then after it's done that, it will check the UART to see if there's any commands waiting. So I'll push the button now, and then when it's finished displaying to the LCD, it will say there setting command to 1, because that's the one that I put in just before. And now when we run it, we'll see something a little bit different. So look at the last one here. We have rectangles, and we have, if you just ignore the ones in the top left which are not supposed to be found, we have 6 rectangles found, and 2 of them are approximately square and 4 of them are elongated. So what we're going to do now is we're only going to try and find elongated ones, and we're also going to draw ellipses instead of rectangles. There we go. So in this way, so what I'm thinking is each time some components are carried across in front of the camera, or before they're carried across rather, you would need to tell the camera what kind of components it should be looking for this time. So it might not be quite appropriate to do this UART transmission the way I'm doing it, where it like doesn't pick up the command until after the last one that's done. So that might be a little bit too slow of a way to do it. And I might be also a little bit paranoid about having the UART transmission check in that tight loop. Might not need to do that. But anyway, we'll see, should see that there's a little bit less blobs found in this one. That last row there. Oh no, we did 2 of them, didn't we? So the last 2 rows should be a little bit shorter than the ones we were doing before. A bit hard to tell, isn't it? But anyway, we could, whoops, let's put that back to 0, and then run it. We'll get one more run with the ellipses, and then we'll go back to squares like that. Anyway, I thought that was pretty cool. That's what I've been doing this week. Yeah, that's all. I'll put the... this is all done in MicroPython, by the way. And obviously you'd need to do a little bit more work to figure out the orientation of the component. Like just finding these blobs is not enough. You need then you need to figure out which way they are rotated in order to correct the rotation for the parts as you're placing them. But I don't know much Python. I've just about the whole time I'm doing this, I'm having to Google everything to figure out how to do things in Python. It's kind of slow, so I haven't bothered to do that yet. But I will put up the code for what I have done so far. I'll just put it in a link in the description of this video, I guess, if you want to have a look at that. Yep. All right. So that is the end of the video. Thanks for watching. Bye.